Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about electroplating. So let's dive right into it. Now what exactly we are talking about here? Well, we are talking about covering one metal with another metal, meaning you have metal A and you cover this puppy up with metal B. Now there are many needs for this, we'll discuss that further, and you have to understand there are two core components that drive this function. One is fluid and another is electricity, meaning you have to have these two things. It's not something that you apply with a paintbrush. It is a fluid bath, quote unquote. And how good your reaction is, that is controlled by these two factors, fluid and electricity. And it has one of the most amazing property, which is very good bonding strength, meaning if you coated something and if the process was done properly, you can grind that puppy in. For example, if you have seen any JVC or any sort of excavator, you see that shiny rod, that's steel rod. Now that steel has been electroplated with chromium. Now chromium is so hard, and if electroplating is done so properly, they can grind the final shape after they have coated it. They got the raw steel, they got it to roughly the shape, they put electroplating on it, and then they did the final grind, and the electroplating will not fall off. Like if you try to do grinding after painting something, good luck with that. So that's why I specified it has really good bonding strength. If done correctly, it's almost indestructible. Now why do you want to go through this much trouble of having electricity, fluids, metal is expensive? Then why? Well, reality is most metals are reactive to O2, meaning oxygen, meaning the things that we use. So consequences are it shortens the lifespan. For example, Statue of Liberty should not be this color. It's supposed to be brown, somewhere around copper and brass kind of color, kind of brown. But what happened? Well, oxidation. So the steel color is literally side effect of oxidation, and it shortens the lifespan. For example, if you are talking about any structurally critical element, for example bridges, and if you have something that is carrying the load, for example chain or something like that, and if this corrodes, that building will fall apart, that bridges will collapse, and it has happened in the past. So this is not something that's like just for looks. It is what we call structurally critical, meaning it must serve its function, otherwise boom. So this is one of the things that we have to understand that. And there is no one metal, like one thing you may like, what if we use this metal? There is no one metal that can do it all. Nothing exists that can do it all. For example, you may be like, hey, how about we use gold for making PCBs? Can you do that? Yeah, physics is like good. What about manufacturing process? That's also good. Cost, good luck with that. So that's, you have to understand that. There is never a metal that is like, I can do it all. For example, you'll have one metal that's like, dude, I'm amazing for conductivity, but I'm really not that ductile. You'll be like, okay, let's make sure they get married together. So that's the whole point. We always need multiple properties from multiple metals, and coating things in precious metal for value add. For example, you can have a copper necklace, and that copper necklace can be coated with gold. Now will it look like gold? Absolutely, because what do you see whenever you are seeing something? What are you seeing? You are seeing the surface of it. If surface is actually coated with actual gold atoms, it looks like gold. Like literally it is gold. For all intents and purposes, it is gold. Will it oxidate? No, because it has the same properties of basically gold. So you get that point. That's how we increase value of things. Basically, you can have medallions, you can have jewelry, things of that nature. You will coat it with that with thing. And if you're not talking about like value add as in like just for value sake, you may be doing that for improving longevity of a product. Like for example, fountain pen, especially expensive ones, they can have very expensive coating done on them, electroplating of platinum. It also improves their longevity and also makes it write very smooth. Now mortal people generally do not know how much those pens cost, and I'm pretty sure it's in the category, if you have to ask, you can't afford it. So that's why we do it. Now what's the process behind it? Well, process is inherently simple, and you must understand liquid electrolyte is the key. That's everything happens in the electrolyte, and electrolysis is the core. If you have studied electrolysis of water, it's the same thing, only difference is different materials are used here. And voltage, basically how much voltage you're going to put into the system, is directly proportional to the metal you are utilizing. For example, there will be a different voltage for copper, different voltage for tin, different voltage like, and what about ampere? Ampere will decide how much oomph is in that system, meaning how big of a surface area you can coat, how quickly you can coat that. So that's how two components are controlled, voltage and amps. And yes, it is electrically energy intensive process. It's not something, of course, if you are doing a small school experiment, it's not a big deal, you can do that with this thing. But if you are doing like as a manufacturing thing, yeah, your power bill will be huge. And this is the pipeline. You have anode. This will be what you will classify as coating material, meaning sacrificial thing, gold, whatever you want to coat on something, that will go into solution. Then solution will go into cathode. Cathode will be the thing that will be receiving the coating that you want to do. So you have nickel, rhodium, gold, metal, whatever have you, that goes to the fluid. Fluid dumps that into the system. Actually, fluid is not dumping the fluid, already has it. But point is, when you drive current through it, basically having electricity going around there, fluid charges, basically ions mixed into the fluid, wants to go here. Now it goes there, that creates a vacancy. Now because you're still pumping electricity, it's like, dude, there is a vacancy there, how about we detach? So it detaches from this puppy. Now the biggest advantage of this system is that solution remains in fixed concentration, meaning once you created your fluid system, and like let's say copper sulfate or something like that, it has a concentration, basically how much copper it has, it will remain fixed. Now like, why isn't we are mixing things? That's the whole thing. The amount of mixing is directly proportional to the coating. Now of course there will be some losses, there will be some contamination, because good luck finding 100% pure metal, but you get that point. So if you, let's say for example, you coated 2 grams of gold into this batch, 2 grams will be deducted from here, meaning the fluid solution, however gold it had in the starting, will be there, no matter no changes at that. So this really makes it suitable for large scale industrial process. So they will have a fluid bath, they will have a sacrificial anode, cathode, and they're like, coating, and after a while they'll just remove the basically anode, and they place a fresh new anode. They do not have to change the fluid. It makes it really easy to mass produce. So fluid remains the same. Now of course you still have to recycle the fluid after a while, once it gets contaminated enough with dirt, grime, things, because good luck trying to find something that is absolutely pure and absolutely clean. And not to mention, you are doing this not in a vacuum environment, so atmosphere will also start to do some love into this. Now which metal can be used? Generally almost all. So you have tin, you have zinc. Whenever you hear about tin can, that's what they are talking about. It's still made out of steel, but it's coated in tin or electroplated in tin. Then you have zinc. When you have galvanically shielded metals, generally iron, that's a zinc coating. Then you have chromium. Now chromium is one of those things that we want to put in almost everything, but A, it's expensive, B, it's kind of toxic, as in like ludicrously toxic, and that's why you will hear people say like, do not try to weld a stainless steel directly inside home. Never do that. Always do it outdoors. Have a proper gas mask for that. Chromium is really not a good thing. It's also used in stainless steel. Chromium is one of those material. Only deal with this if you know what you're doing. Gold and silver, we have been doing that for 100 years. Nickel, one of the like type electroplating, nickel would be the first thing. Copper, not that useful, but it is desirable for many scenarios. And then you have platinum, if you're really fancy, or you are a car company that is trying to make catalytic converter, they have a lot of that. Or if you are Iron Man, palladium. It does have some uses, but you get that point. And be very mindful, not every metal is compatible. For example, if somebody is like, hey, I have this steel spoon, I want to make it into a silver spoon, you can't do that. You have to coat steel with copper first, and then you have to coat it with silver. I did talk about bonding strength to be really good, but be mindful, it is still a chemical process. You have to be mindful of that. If you try to bond something dissimilar, something that does not really want to do that, your coating will be like, poof, gone, coating gone. So that's why whenever you hear something coating with like steel, and they are saying, this direct coating, generally there is talking about chromium. It does look very close to silver, so people can be fooled into that. And that's why people generally will not have direct coating for everything. You will have, there are some limitations, so be mindful of that. So that's the process behind it. Now what are the uses? Like, why did I go through this much trouble and this much electrical bill? Well, reality is it's cheaper and better than painting. For example, that's the inherent use of it. I have provided a small scale company before that generally takes shopping carts. You have seen shopping carts, and they are made out of steel. Now you may think, why don't make out of stainless steel? Yeah, you can make them out of. Good luck trying to find a buyer that's gonna buy that. It would be too expensive. So we make it out of steel. Now you can paint it. People did try that, but it does not last very long. So fundamentally, electroplating was selected. Now electroplating, it's just a dipping process. It's just like dip it in one to clean. So dip it to rice, clean it. Dip it rice to acid bath it, then dip it into this solution, then dip it into this solution. It's like step-by-step process, dipping process. All that is much cheaper and better than painting. Better as in like, because there is liquid, and because the liquid, you are dumping so much energy into the liquid will be boiling almost, and it will be circulating a lot. And many plants actually have air circulation, like making sure it's like very agitated. So coating efficiency, meaning like how much area is coated, that's almost 100%. If done correctly, if you dial down your setting, you will be talking about 100% coating efficient. Good luck trying to find a scenario where you can paint something 100% efficient. Meaning every single square centimeter has been painted. It's very difficult, and it is super easy to automate. That's one of the things that we have very huge demand of almost everything nowadays, even including toilet paper. So we do want to automate. Look, that's how all the process is, like dunk, go, dunk, go. Of course, dunk, time, wait for it, and then go. So it is super easy to automate, as in like it has been automated in like 1900s kind of automation kind of thing. It's super easy to do that, especially on large scale. If you know, like let's say my company, all they are doing is like electroplating car wheels, rims. That's it. Like you will make a plant and like forget about it. It's like done. It's like you will barely have like 2-3 people just maintaining the electrical systems and just double checking everything. Other than that, nothing. Super easy to automate. Supports very large scale, meaning you are talking about hundreds to thousands and thousands of parts per hour can be processed, which is really fast. It does extend lifespan, meaning if you are spending money for this, is it giving you something in return? Short answer, absolutely. It is actually giving you something in return, and it does enhances value. For example, if you are doing gold coating or silver coating or things of that nature, and for example in electricity, if you have seen any graphics card, which are rare nowadays, but if you have seen their PCBs, they have copper. Then the pins, they look goldish. Why the heck they look goldish? Because it has gold coating. And I'm like, why the heck somebody bothered to put gold there? Well, reality is copper is awesome. If you really want to send some GG amounts of ampere and current, copper is like, I got you, fam. But here's the problem. It still loves oxygen. It still wants to get married to oxygen. And you're like, you really should not do that. So we apply gold as a divorce lawyer, so to say. So it's like, no, we will not allow you to get married. So that's the whole job of gold here. It makes it last longer. And again, why don't you make it out of gold? Well, good luck. Some satellite circuit boards have been made out of gold, but again, it's very, very expensive. So that's why you will always find like when you are very critical, you do not want oxidation to do, and it does have some other benefits also. Basically, contact resistance also goes down, so it does have some other benefits also, and that's the whole point. Copper will do the bulk loading, and you will improve the efficiency with using gold, just a limited amount of gold, enhancing value. That's why we use it. It's really amazing, surprisingly so. Now, when I'm talking this much about it, you will have an itch. How about I do it myself? Well, it can be done. That's the good news. It can be done, and you'd only need like almost 4 core components. Component number 1, a power supply. Now be mindful, people have successfully done it with battery. People like in school experiments, that's what they would urge you to do. But if you really want to do it properly, get a voltage system, because, and again, you do not need like the latest greatest. It's like big around if it has like power control of around 12 volts, 2-3 amps, more than good enough, of course. And you generally would be in lower voltage setting, and this will also allow you to fine tune the settings, because what can you fine tune if you're using a, let's say, USB power output? What can you tune? It's like it's fixed at 5 voltage, 5 volts. So that's why a power source, good enough. Like, it does not need to be latest and good enough will do. Pure metal. Now this is expensive, and many times people get cheated when they're like, hey, I'm buying pure nickel strip, and they're like, wait a minute, it's something else coated with nickel. So you have to be mindful of that. Getting pure metal is a bit difficult, not impossible, but difficult. And if you buy a normal copper and you're thinking it's pure, well, it would be pure to a very large extent, but it will have not only oxidation damage, and it may also have little bit of alloying. So pure metal is a bit difficult, but can be done. Then you have vinegar, basic stuff. Then you have cleaning acid, generally HCl. Now that is a bit of a problematic thing, but it can be done. Without it, be mindful, your coating would be lol if you do without it, simply because we use acids are very good at removing oxidation layer. They are very good at that. And if you are talking about something like, you may think that does not oxide, like aluminum. That's the first thing aluminum creates. The moment aluminum is exposed to environment, it oxidizes. It creates a layer, and now that layer is quote unquote bonded with it. That's why that layer itself is protecting from further rust. That rust is protecting from further rust. How do you remove it? Because if you coat directly on top of that, it will try to do its best job, but it's coating to something that is already oxidized, so it's not very stable. The bonding strength would be very weak. That's why you have to use something like acidic. Now people have tried using isopropyl alcohol with mixed result. Grinding it has provided a very good results, but result may vary. Generally, for every manufacturing process that is actually doing this for a living, they are like, yeah, we have to use acid. There is no bypass, and that's why you do not see this puppy done on large bulldozers. It's like, bulldozers are big enough, expensive enough. Like, why the heck you are still painting it? Yeah, doing electroplating on them would be a bit more expensive, and not to mention trying a bath that is strong enough that you can dip a freaking bulldozer in it. Yeah, even just the track section, that is the most strained part. That part also would be very difficult to do, but you have to do this in well ventilated places, meaning you could have gaseous output which may include hydrogen. So fundamentally speaking, Do it outdoors if you can, and if you are doing somewhere, try to do it near window with have a fan that is like sucking everything out. It's like, don't think about it, and take your time. Do not rush it, and do not try to use plastic containers. Some people have done that. It does work, but be mindful. If you have power, the first thing you will feel like, how about we put some love into this? It will work, but water will start to heat up, boil up, and you could have a scenario where that container will itself collapse. It has happened to many of people. Again, it's just a messy situation, so just use glass. And that's why, if you ever notice like, why the heck everybody is like, who has good output generally have glass jars, that's the reason for that. Glass can withstand much higher temperature comfortably. And again, in factories, whenever they are using plastic containers for that, those plastics are much higher temperature resistant, and the rim where they are putting the electrodes, those rims are reinforced, so they cannot survive the high temperature. So, and I have provided some videos down below which are one of the best I have found so far, so use that. Now be mindful, make sure you have all these 4 things, then go into that, and do not get carried away into this, please. This is a good and small fun experiment, but do not try to do in large scale. Do not try to coat your bike and all that, not because you cannot do this, simply because these materials, once you are talking about large scale, are classified as industrial toxins, meaning it has to be handled properly. Now of course, if you are dealing with like few grams, nobody's gonna notice, but once you have like large enough collection, especially in Europe, they're gonna come for your ass. And even in India, it's like, if this is something that people take very seriously. I specified chromium is not a child's play, so be mindful. Experiment with this, learn it, good, fun, awesome, but be responsible. There is a reason why we have factories for this. So this was my presentation on electroplating. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, and I would urge you to comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.